All right, we're going to get started here. My name is Justin Kramer. I'm currently a neuroradiology fellow at the University of Utah. And the purpose of this video is to show you how we go about creating 3D models from CT images. So I've chosen the myelogram that we segmented for our lumbar puncture and spine procedures books. This was a myelogram performed on a young healthy patient, so not a lot of degenerative disease. And we're going to go through how you create a model using Materialise's software, which is Mimics and 3Matics. And what you see here is Mimics. This is the portion that's responsible for segmenting a medical image. So this whole presentation is it's a little bit unrehearsed, almost intentionally, just to kind of show you all the pitfalls and a real practical workflow of how you segment a model. So here we have the lumbar spine, and this is imported into Mimics. I'm not going to get into detail on that. It's pretty straightforward. Basically, I have an anonymized DICOM data set, and through the new project wizard, I was able to import that DICOM file. This was a study that had 0.6 millimeter sections, so it was very thin enough to do MPRs and create a smooth 3D model. So the first step to segmentation is called thresholding. Now we're going to use kind of a cooking show approach to this. You can see I already have a lot of stuff segmented out, and I'm going to show you how you get started segmenting, but to spare you the numerous hours of tweaking the model, we're going to kind of skip ahead to a fully segmented model eventually. So to get started, you can click this New button here, and that brings up the thresholding module. And basically what this does, you can see it defaulted to the bone algorithm, and it says every pixel that has a Hounsfield unit value between 1250 and 4095, we want to capture that and make that part of our segmentation. So we're just going to click apply, and that's going to create a new model here. It's going to be called green 2. I can rename that to everything for demo, for example. And you can see here right away, if you want to segment out the thecal sac and the bones separately, it's a little bit tricky because they have similar densities, and so both of them are automatically included. So one of the things we want to do is separate out the thecal sac from the bones. And unfortunately, this was a pretty laborious process. So I'll show you how I go about separating two structures. Now, for the sake of argument, let's say all we're interested in is L1 through L5. So we're going to start here, and you can make this zoom. And basically, what we're eventually going to do is we're going to grow a region. We're going to click on a pixel and say, include every pixel that's connected to this one in my segmentation. So what you have to do is you have to disconnect two structures so that when you grow, you're not including a certain structure anymore. So the other thing that you can do also is Boolean operations. So you can subtract one segmentation from another. So if we are able to fully segment the bones without the thecal sac, or the thecal sac without the bones, then we can go the other way as well. But for simplicity, we're going to start and just take out the thecal sac. So this is going to be bones for demo. And for subtraction purposes, we can actually just keep this as everything for demo, and we can create a duplicate and call this bones. And then let's create another duplicate. Call this thecal sac. You'll find out you're going to get a ton of these are layers here, or masks, and you're going to get a ton of these. And it really pays off to name things smartly so that it's not confusing later on. So this is our bones here. We're going to show that. And then what we want to do is we want to take away the thecal sac. And the way I do this is with the multiple slice edit tool that I just clicked there. And this allows you to go slice by slice and make modifications. Now I'm going to use a circle tool I'm going to give it a width of, say, 12 pixels. I'm going to apply it to the axial slices, which is what I'm working on now. And what I want to do is I want to remove anything that I've highlighted. I'm going to get a little bit bigger circle, and then go through and take out the thecal sac. So you see I highlighted here, and if you click apply, you can see that the thecal sac is no longer present. Now, this is kind of my cutoff. I don't want the superior part of the thecal sac to be part of the segmentation, so I took that out. Now I'm going to go through and I'm going to try to take out anywhere that it's connecting to bone. So you see here, all these little pixels are connecting it up. But it's okay, you can just do that and you can break the connection there. Now, since this is the bones, I don't want to take out parts that are bone. And I just want to take out areas of connections. You can see that it starts connecting posteriorly here too, and you want to take that out. And you missed a spot here. And the important thing is, if you miss a single pixel, it's still going to be thinking it's still going to be connected. And sometimes you segment out, spend a lot of time trying to break a connection and then find out that there's a connected pixel somewhere you weren't seeing, and that can take a while to find. So just doing this, and this takes a while. When people say segmentation is time consuming, that's what they mean. And so you can see I'm just going through layer by layer here. And then if I click apply, it will have taken out all of the connections that I had there. Now, one important gotcha is I was using Google Drive to back up all of my progress as I went, and I did discover a conflict. Google Drive would lock the files in a way that Mimics didn't like, and I was getting crashes. So I would advise turn off Google Drive while you're doing segmentations and working with Mimics. But I'm going to save this here. Save often. These are complex operations. Sometimes you can get crashes and you don't want to lose your work. So I would encourage you to save often. So we would go through like that, and I basically went through slice by slice and was outlining the thecal sac on every slice and taking that away. And it took quite a while. So let's assume that we have taken out the thecal sac. Let's look at the bones model. We're going to unzoom. We have to close the multiple slice edit tool. Unzoom from full screen. So you see here, this is a model of the bones with the thecal sac taken out. And you can click here, and you can see here, here's a segmented thecal sac, 1 through 5. Okay. The other thing I wanted to do was have each vertebral level available as a separate model. And as you can see here, it's all one model. And so in a way similar to the thecal sac, you also have to manually pick apart the bones. And the way you do that, if we go to say, bones for demo, this is going to be the thecal sac included, but you can use your imagination here. I found it easiest to pick apart the bones on the sagittal sequence. And so we're going to do the same thing. We're going to remove, and let's say we want to isolate L4. Well, so we're going to go through and we're going to remove the connections at every level. If you apply here, you can see, all right, this is just L4. And you go to the next slice. You remove the connection here. Now, one thing that's kind of helpful, you can zoom in, give you more control over your pixels. So this is a time-consuming process, and I was trying to create models for educational purposes and wanted to have a lot of flexibility. In general, if you're doing it for clinical purposes, maybe you only have to just use a crop tool and cut off half a vertebral body and not worry about it. But we were trying to create nice models for books and things like that, so we spent the extra time separating things out. But separating the thecal sac from the vertebral bodies is pretty desirable because you want to print them separately also, perhaps in different colors. So that was kind of unavoidable. So anyway, you go through slice by slice and eventually separate all the bones from each other and separate all the thecal sac from the bones. Okay, so unzoom, and now we have all these different layers, and I'm going to show you how that works. This is kind of my finished product. So I've got all the bones separated, and I can click on L1, L2, L3, L5, and these are kind of optimized L3 and L4s that I tuned up a little bit. So you can see here we've got L1 through L5 as separate bones, and then we have a separate thecal sac. Now, see what that looks like. That's the whole thecal sac. And then we have a thecal sac L1 through L5 right here. Okay. Now, one of the things you're going to notice about the thecal sac is I actually put in nerves into my segmentation. This was kind of an imperfect process. I was doing some guesswork. You can see here that if we go up a level, you can make out nerves coming out even on a non-contrast CT. You've got a dorsal root ganglion here, and then you can kind of follow it down. But it definitely takes some imagination. Nerve here, a nerve here. So I traced it out of the thecal sac a ways so that I would have nerve root sheaths modeled as well, and you can kind of see what I did there. And that was also a pretty time-consuming process. But this is kind of the finished product as we're scrolling through it. So once you have all the segmentation done, that's kind of where the fun part begins. You have data that you can generate a model from. So the next step is you want to create a 3D model from all of this. So if we unzoom, you can see here, this is our 3D model window here. I'm going to turn off those reference planes. And so what I'm going to do is I'm going to highlight L1, L2, L5, L3, L4, and the thecal sac. Those are all the things we're displaying right now. I've control selected those, and then I want to calculate 3D from them. I'm going to use optimal quality and calculate. This takes 20 seconds or so. Okay, so here we go. Zoom to full screen, and this is the pan tool. We can use that, and then we can rotate it around. So you see here we have a model of the lumbar spine, and that's how we got there from a CT. The disc spaces aren't segmented out. That would be more hours of segmentation time, but that's what we have. Now, I'm going to show you some of the CAD things that we did in 3Matic, and so what I'm actually going to do is just 2 levels. So we'll delete these. These are all the 3D objects, and you can delete and duplicate and copy those as well. But basically what I want to do is look at L3 and L4, and then I have a thecal sac from L3 to L4 as well. And I'm going to calculate a 3D from those. Okay. So here's 2 levels and a tiny thecal sac with nerves coming out at L3-4. So I want to do stuff to this model now, and that means you need to get it into 3Matic. So what you can do is you can export to 3Matic, and that's how you get it in there. And you have to select all the objects. You got to leave Mimics open while it's doing this, but it just takes a second to start that up. Okay, so now I'm going to close down Mimics, and here's our model. So some tricks: if you right click, you can move the model around. If you go to the side of the model and right click and get this turn arrow, you can rotate the model. So those are 2 of the big operations you're going to use, and then if you scroll up and down, you can zoom in and out. And then if you hold down the shift key and right click, you can pan the model. So we can rotate it around with a right click, turn it with a right click at the edge, pan with a right click and shift, and scroll. It takes just a little bit of muscle memory, but once you get it down, it's pretty useful. So you see here, this is the scene tree. These are all the different elements that we've exported into 3Matic, and you can do all sorts of stuff with this. You can hide certain levels, and this is why it's nice to have certain levels segmented out, especially if you're going to create graphics or something. You can adjust transparency. So, if you want somebody to get an impression of what it's going to look like under fluoroscopy, you can have a transparent model. Okay, so one of the things that I want to show you is how you post-process a 3D model. What's kind of the basic number of things that you want to do to a model before you try to print it? Well, there are some basic post-processing steps to go through first. One of the things is called a wrap function. Now, if you look at this model, you can see there's little holes, kind of little holes everywhere. Another thing is called a smooth function, and you can see here that there's some little bumps from the segmentation process. It's not perfect, so you can apply a smooth operation to make it more smooth as well. So let's do a smooth, and you can see down here this is your smooth operation, and if you click entities, you can add every entity so that you just smooth them all at once. Smooth factor, as the number gets bigger, it smooths it more. You can just kind of play around with that. You can make extensive use of the undo function as well. It works for everything. So if I do 0.39 smooth on all those elements, and some of these operations can take a little while, especially depending on the speed of your computer. If you've never worried about hardware and GPUs and graphics cards before, you might find yourself doing that if you get into this. So you can see it looks a little bit smoother. Some of those jagged edges are taken out. And let's do that wrap function as well. Seal up any holes. And we're going to use the wrap function on every model. Gap closing distance of 1.5 millimeters. So if you've got a 2 millimeter hole, it's not going to close that. So we'll apply the wrap function too. Then after we're done with the wrap operation, the next thing we're going to do is fix the model. And what fix does is basically correct any errors in geometries so that it can be understood by a 3D printer. If you have an unfixed model, you could run into difficulties when you're trying to print. So this wrap operation is taking a little bit. All right. So you can see the wrap operation actually creates a duplicate model, and this is where hiding becomes handy. You'll run into duplicates. I'll create a lot of duplicates also, just so I'm not completely reliant on the undo function. And you can rename things also. So you can say this is L4 smoothed, L3 smoothed, fecal sac smoothed, and this is wrapped and smoothed. But you can see here, it did a nice job of closing in the holes that we saw earlier. There are going to be some areas that don't completely fill in. And there are some CAD operations to do that. Sometimes if I have a hole that just won't close, I'll actually go back into the segmentation tool and fix it there. It's pretty straightforward. You just go in and with the multi-slice edit and add a little bit of segmentation there and re-export it to 3Matic. It's pretty easy to do that. So then we want to fix our model also. And we're going to use the Fix Wizard. And you can only do this on one part at a time. So let's start with L4. And basically you can just click Follow Advice, and it automatically does what it wants you to do for the next step. But you basically click Follow Advice a lot of times and hope that the model gets fixed. So that just fixed a bunch of noise shells. You see here we have 6 overlapping triangles and 7 shells. Now I will freely admit I don't exactly know what those are. I just keep clicking until I get green. And if eventually there are problems that can't be solved, I just go with it anyway and see if it'll print. And usually it does. Usually the problems you're left with don't keep you from being able to print. So we have 3 shells and 6 overlapping triangles. We'll call that good. I'm going to save it. We'll just call this our demo. This is a .xp file. I pay a lot of attention to keeping things very organized. We've got a folder that has everything. It's all anonymized, but you got mimics files, which are MCS files. You've got 3Matic files. But for now, we'll save that on the desktop. Okay, so the next thing I'm going to show you is how to do some stuff to your model. Now, one of the things we did was we actually created a model that snapped together. The anterior and the posterior parts split at the pedicles and had a dowel that would allow you to snap the model together. So you could print out the bones first, print out the thecal sac, slide the thecal sac on, slide the bones together, and have a model. Or have a multiple color print. And our printer only prints one color at a time. And so I'll show you how to, basically split a part apart, add a cylinder to that, and unify the parts. So the first thing we're going to do is split them apart. And we're going to do that by creating a datum plane. And basically, I'm going to need to orient it like so. Drag it around. Okay. Create a datum plane. And you have to orient it in space with 3 points. So I kind of just try to specify 3 points that get you in the right area, and apply. And now let's look at where this plane is going. And it's basically cutting the vertebral bodies down the pedicles. So I like that. Okay. Then, once you have a plane that's cut the way you want, you go to Design, Cut. You're going to cut L3 and L4 entities with the datum plane as the cutting entity. And you might want to create a duplicate of these also because it's going to cut these. But I'll just apply it. Alright, so here we go. Got lots of different parts, anterior and posterior parts of the vertebral bodies. So you can see here, if we hide that, we now have that cut. Okay, so let's hide the front parts. And these are just our posterior elements. Now let's say we want to have holes in the posterior elements and dowels coming out of the anterior elements. So what we're going to do is we're going to create a cylinder. We're going to create a primitive cylinder. And the radius is going to be 4 millimeters. So that seems about right. That'll be an 8 millimeter thick cylinder. Maybe we'll go with 3 millimeter radius. And then 2.5 centimeters long, 25 millimeters. Let's say it only needs to be 1.5 centimeters long. Okay, so it just created a cylinder way up there, and we want to get it down to our model. And this is where just knowing your way around the software is helpful, because it can be a real pain otherwise. So you've got some align options here, and we want to do interactive positioning, and we're going to click on the cylinder as our active object, and then once you click, boom, it automatically sends it to where you want it to go. Okay, so that looks pretty good. You know, that's a cylinder sticking out of the posterior part, and you're going to want all of the cylinders to be parallel to each other, because otherwise as you're sliding in it would be a problem. So what I do is create 4 copies of it, and then I just drag it in the X, Y, or Z plane and don't do the interactive position anymore, because I don't want the orientation of the cylinder to change. So we'll call this right L3, and again, would really encourage you to name. It's going to save you a lot of trouble in the long run, but we're going to duplicate these all right here, and left L4. Okay, so now we can do an interactive translate, which is just moving something in space. So let's say we want to translate left L3. We want to take it over there. And we can do that. And as long as you're not rotating it, you can kind of move it around a little bit, and as long as they're parallel, they're going to slide together okay. So we got that aligned. And now we're going to align the right L4. So we still have the interactive translate tool up here, and we're going to align right L4 now. So drag that down and over. And then we're going to align the left L4. So pick our entity as left L4, bring it down and over. Okay. So now what we need to do is we need to make the cylinders part of the posterior elements, and we need to subtract them from the anterior elements. And what we're going to do is we're going to make some duplicates, because it's going to integrate the cylinders into each model. So I'm just going to duplicate all of these by selecting them. And so the first thing we're going to do is subtract them from the anterior elements. So let's go ahead and hide the posterior elements and show the anterior elements. Okay. Now everything's still in place, so we're still got everything lined up. So all we want is holes in the front parts of the vertebral bodies. So what we're going to do is a Boolean subtraction. We're going to subtract the cylinder from the vertebral body. So we do a Boolean subtraction, and we're going to can just pick one entity at a time. And so we'll pick L4, and we're going to subtract the L4 right cylinder from it. Okay. Okay, so subtraction result 1. Now these are what we're going to use later, so let's hide those. All right. So there we are. Now we're going to subtract the subtraction result, and we're left with the left L4 entity. Let's do that too. All right. So there we go. We have 2 holes in there. Now we're going to do the same thing for L3. We're going to take L3 and we're going to subtract the right side. Apply that. And we're going to subtract the left side. Now, this is L4. L3. We want to have L3 be our entity. Let's remove that. It doesn't like to have the same thing be the same entity. So L3 is our entity, and then subtraction is going to be left L3. Apply. Okay. So there we've got L3 and L4. I think I selected the wrong thing, so this is actually an L4 cylinder. So here we go. And looks pretty good. Now you could add some clearance to that, a clearance factor of 0.2 millimeters, which you may want to do. If you're going to print out these cylinders, you're going to be sliding them together, and they could be kind of messy, or rough models, so you may actually want to add in clearance to your cylinders before you do the subtraction as well. If you wanted to sort of have control over the cylinder, the clearance yourself, you could also do a uniform offset, which would create a cylinder that was, say, 1 millimeter bigger in radius than the cylinder that you had. So for now, we didn't do any offset whatsoever. I had to do a fair amount of sanding out of the model to get them to fit together that way. So using an offset is probably advisable. So this is our L4 anterior, L3 anterior. Now we're left with L4 posterior, L3 posterior. Okay, so we're going to hide the anterior because we got those the way we want. And we're going to show the posterior, and we're going to show all our cylinders also. And so there we go. Now we just want to make these, part of the same thing. So we're going to do a Boolean addition, Boolean union. And we're going to union L3 with L3 posterior with the right L3 cylinder and the left L3 cylinder. You can see why it's important to name your stuff, otherwise it gets confusing very quick. So we're going to join all these together, and then we got a union result. We'll just call that L3. Actually, we'll call it L3 posterior, just to keep things straight. And then we're going to do another Boolean union. I'm going to take that out, and we're going to union all of our L4 elements. And you got a union result here. L4 posterior. Okay. And there we go. So now if we show the anterior and make it transparent, this will allow you to nicely see what we've got. We basically have anterior elements that are going to print out with a hole and posterior elements that are going to print out with pegs. And it should be able to slide together. And I did the same thing for the thecal sac as well. And basically, you can, if you forget to duplicate everything, you can pull it out of the union object on the surface list, and you can ungroup it so you can sort of reclaim your cylinder and then regroup it. But basically you go through the same procedure with the thecal sac to create dowels and then holes in either the posterior anterior vertebral bodies. But for now, let's just say we're going to print out the vertebral bodies and we want to get these as STL files. So the last thing you do is you can export it to STL. And you can see there's quite a few other file types that you can export to, but let's go with STL. And we're going to export all of them. Let's say we export them to the desktop. I'm going to include the colors. So if you wanted to color these, another way, I'll show you that real quick. These are the object properties here. So let's say L4, L3 posterior, you don't want it to be pink. You want it to be colored like a bone. So you can change colors here. And these are for all the different surfaces of the model, but you can see that the front face was the majority of this model. Anyway, so if we're going to export all those to STL, L4 to the desktop, scaling factor would allow you to make a smaller model. So say you want 75% size, well, you can just 0.75, something like that. Okay, so let's go 1-to-1 size. And now if we look at the desktop folder, we've got our STL files here. Okay, L3 and L4. All right. We'll save this. And then printing it is just a matter of loading it up into the software provided by your printer, and we'll talk about that in another video. So that is it. We welcome your comments on this and be happy to answer any questions you might have as well.